Today we're talking about quadratic functions, and in this video we're going to start talking about some of the key features that you will see in the graph of a quadratic function. Okay, so first of all, when you graph a quadratic function, it's actually going to end up making a U shape. So it's going to look like a U shape. And when it's graphed, the function, that U shape that it makes is going to have a name. It's called a parabola. Okay? And that parabola, that U, can either face up or open up, or it's going to open down. Okay? What you will not see with quadratic functions is you will not see that it opens sideways, because if you think back to what we talked about with functions, if it opened sideways, it would not be a function because it wouldn't pass the vertical line test, okay? So when you graph a quadratic function, it's going to look like a U, okay? And so you can see one down here. When you graph it, there are going to be some key features that you're going to have to look out for and be able to describe the graph, okay? So one of those key features you kind of already know about from other functions. One thing that you can look at from the graph is called an x-intercept. So an x-intercept, if you think back to before, it's where the graph crosses the x-axis. So it's where it crosses the x-axis. Okay, so you're looking for those points where it crosses, okay? Now, if you look at this graph, you can see that we have our U-shaped graph, our parabola is graphed, and so we're going to look at our x-axis, which is this one right here, to find our x-intercept. So that point right there would be an x-intercept, and then that point right there. And so you can just name the point where it crosses it, or if you write them as coordinates, this coordinate would be at -1, 0, so that would be one of our x-intercepts. And then the other one is right there, so that's 1, 2, 3. So that one's at 3, 0. So that is one way of describing your graph, is by looking at the x-intercepts, okay? Now, this part is going to be a little different. X-intercepts actually can have a different name whenever you are dealing with quadratic functions, okay? So x-intercepts, when you're dealing with quadratic functions and other types of functions, which you will get to in other classes, could also be called, so you will need to know that by these other names, so it can also be called zeros. It could also be called roots. And then you're also going to classify them as solutions, because whenever it asks you to solve a quadratic, you're going to be typically finding the x-intercepts, where it crosses the x-axis. So these x-intercepts could also be called zeros, roots, or solutions, okay? So if you see a problem and they're asking you what are the zeros of that function, you're looking at for the x-intercepts. You're looking at where that crosses the x-axis, okay? So y-intercepts. Well, the y-intercept you would have learned from other things that we've done. The y-intercept is where it crosses the y-axis. So where the graph crosses the y-axis. And so to find that, if it's graphed for you, you're going to look, and you're going to look at where it crosses the y-axis. So that would be right here. So where does this cross the y-axis? Well, it crosses it right there. And so to find the y-intercept, you can write that as just a number for where it crosses it, or you could write that one as a coordinate. So for the y-intercept, that would be, you don't go left or right, so that would be 0, and then where does it cross the y? So 1, 2, 3, it crosses at -3. So the y-intercept would be -3, or you could write it as the coordinate 0, -3. Okay? Now, specific to these types of figures, to parabolas, you're also going to be talking about a vertex of your graph, okay? So the vertex of a parabola is actually the turning point, the point where the parabola turns of that U. So it's the turning point of your U shape. So if you kind of look at your graph, you'll notice that, and remember, you read graphs from left to right. You read them kind of like a book. So if you're reading it and you're kind of tracing this graph, there is a point where, like, notice it's going down to begin with. There's a point where it kind of turns around and goes the other direction. So that point is called your vertex, the point where it turns around, okay? And so if they ask you for the vertex, you just tell the coordinate of that point. So for this parabola, it is at 1, negative, let's see, 1, 2, 3, 4. So it'd be at 1, negative 4. Okay, and so that would be the turning point of that parabola. Now, getting a little bit more specific, they're going to have you classify that point. They're going to either have you classify it as a maximum point or a minimum point. So remember, maximum is like the highest that something goes. That's what maximum means. And so to have a maximum in a parabola or your U shape, you're going to have a top point to it. So some of these won't have a top point. Like, notice, if you look at the top of this graph, this keeps going up. That's what those arrows mean. And so those won't have a top point. Well, then what kind of shape will have, or what kind of graph will have that? So remember, parabolas can either open up or down. And so if your parabola, your U shape, opens down, you're going to have a top point. So when your graph looks like this, so in other words, the U shape opens down, then that's when it's going to have a maximum point, because it'll have a top point to it, okay? So then what does this one have? Well, this one actually has a point at the bottom of the graph where it's turning. And so this would actually be called a minimum. So when your graph or your U shape kind of opens the other way and ends up having a bottom point to it, then you call that point the minimum, okay? So this graph has a minimum at that point. So this would be called a minimum, and it does not have a maximum because there is no maximum to that graph because it keeps going. So you don't have a top point to it, okay? So that's another way of describing your graph, is describing it with a vertex and then saying if it's a maximum or a minimum, okay? And then the last way that you can describe the picture and the last key feature of your graph is by describing the axis of symmetry. So axis of symmetry is similar to like what you did in other grades with line of symmetry. And so notice your parabola, if you kind of draw a line down the middle of it, it kind of looks the same on both sides. So that line that kind of splits it in half is called your axis of symmetry. And so the axis of symmetry is the line of symmetry for the parabola. And so to actually describe that or write down what the line of symmetry is, you have to actually write the equation of that line. So the line of symmetry for this graph would kind of split it in half. And so we're going to have to review, and hopefully you guys remember how to write the equation of a line like that. So that's the line that goes to the middle of it. Because it is a line, we're going to have to tell the equation of it. So think about what the equation of a line that's vertical like that looks like. Remember, it hits the x-axis at one point. And so the axis of symmetry, it's going to be x equals, and then remember, you just have to tell where it crosses the x-axis, which notice it crosses the x-axis at 1, and it happens to be, you know, whatever the x value is of the vertex. There's a reason for that, because it has to go through the vertex, okay? So if you remember it that way, you could just write down for the line of symmetry, it's x equals, and then wherever it crosses the x-axis, or it's the x value of the vertex. So your equation would be x equals 1 for the axis of symmetry. Okay, so those are all the key features of the graph. So they could very well ask you to list out the key features, and you would just find all of these key features of your graph. Okay, So something else that they might have you do is they might have you actually graph the function. So they will give you an equation, and this is a quadratic equation. Okay, the thing that makes an equation quadratic is you're going to have an x squared in it, and that 2 as the exponent will be the highest exponent you have in your graph, okay? Which we'll get into a little bit more specifics in the next video, but this would be a quadratic function. So if they had you graph it, then one way that you could do that is you can make a table. So remember, with any equation that they give you, if you need to kind of know what the graph looks like, you could always make a table. So we're going to review that, and we're going to graph our function, and then afterwards we're going to practice finding our key features of our function. Okay, so to make a table, remember you're going to plug in values for x in your equation and get your y values for them, and then you graph your coordinates that you found. Okay, now as to what x values you choose is actually up to you. So for me, if I don't really know what something's going to look like, I'll just start by plugging in a few negative numbers. So maybe like plug in -3, -1, and then I always plug in 0 because 0 sometimes does weird things. And then I plug in a few positive numbers. So I'm going to plug in a 1, a 2, a 3, just to see kind of what it looks like. And then if I need to do more coordinates or plug in more x values, I can, just to get a better look of my graph. Okay, so all I'm going to do is I'm going to take each of these numbers and I'm going to plug them in for x in my equation. So like to find the y value that goes with this one, I'm going to take my equation and I'm going to plug in a 3 everywhere, or excuse me, I'm going to plug in a -3 everywhere I see an x. So I'm essentially finding the value of the function when x is -3. Okay, so it'd be equal to, I see an x right there, so I'm going to put parentheses and then plug in a -3. And then I'm going to write the rest of it. So -6, there's another x, so that means I have to plug in my -3 right there too, and then just copy the rest of my equation. And then from there, I would plug it in my calculator, or you could simplify it by hand, depending on if you have a calculator available to you or not at this point in the game. But then you plug that in your calculator, so be very careful when you're typing it in, and make sure you don't make a mistake with like mistyping something or missing a sign somewhere. And then when I plugged it in, so here's where I plugged it in my calculator, or if you're using Desmos, you'll plug it in Desmos. And then notice I got 32. So that is the y value that goes with that one. And so I'm going to do the same thing with all the rest of these. So if I plugged in -2, it would be -2 squared, and I have to put in parentheses -6 times -2 plus 5. And whenever I plug that one in, I end up getting 21. And then I would plug in my -1. So it'd be -1 squared -6 times -1 plus 5. And so when I plug that in, I get 12. When I plug in 0, that would be 0 squared, which is 0, -6 times 0, that would also be 0, and then I'm just left with 5. So notice this, if you think about it, that's your y-intercept, so you already know what your y-intercept is. And then when you plug in 1, I end up getting 0. When I plugged in 2, I ended up getting not -2, but -3. And then when I plugged in 3, I ended up getting -4. Okay, so what I'm going to do now is I'm going to take my coordinates and I'm going to graph them. Now, I do want you to see, like, these coordinates, if I was graphing it on one of our graphs that we have available to us in class, those wouldn't fit on our graph. So I'm going to graph some that will fit on my graph, okay? And so I'm probably going to try to squeeze this -112 on my graph, and then if I need to plug in more x values to get a better picture of what's going on, I can. But remember, because this is a quadratic function, it should end up looking like a U shape on my graph. So if you don't see the U shape by the time that you've graphed these, then you probably need to plug in more x values to see what it looks like, okay? So I'm going to graph it. So I'm going to graph the -112. So -112, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That would be right there. There's that point. And then we have 0, 5. So 0, 1, 2, 3, 4, 5 would be right there. 1, 0. So 1, 0 would be right there. 2, negative 3. So 2 and then negative 3. 1, 2, 3 would be right there. And so you could kind of see that you've got part of your U, but remember, you have to see at least a good bit of your U. So I can't see all of that yet. And then we have 3, negative 4. So that's 1, 2, 3, negative 4. So that was at 3. So then negative 4 would be just one more down. Okay, so now I can kind of see that it looks like it's starting to level off, but I can't see the other part. So that means I'm going to have to plug in more x values. So maybe I'll go a couple more. So let's say I plug in a 4 and then I plug in a 5 just to see. So if I plug in 4, that would be 4 squared minus 6 times 4 plus 5. So if I do that, I end up getting negative 3. And then if I plug in 5 squared minus 6 times 5 plus 5, it ends up being 0. So let's graph those and see if I can see more of my U. So the next one would be at 4, negative 3. So 4, negative 3, it actually, notice it starts coming back up. And then 5, 0 would be right there. So now I can kind of see. So it'll start coming back up. And remember, these are symmetrical, so once you have one side of your U, the other side will look the same. So now I know kind of what my graph is going to look like. So I can draw my U shape that goes through them. So once you kind of see the U forming with your points, you can draw it, and there you go. So there is your graph of that quadratic function. Okay, so excuse me, from here, it's going to ask you to find the key features. So we're going to go through and find these key features of my graph. So the x-intercepts would be where my graph crosses the x-axis. So for this graph, I'm looking at where it crosses the x-axis. So it crosses right there, which is at 1. And it crosses right there, which is at 1, 2, 3, 4, 5. And you could also look at your table to see that if you remembered how to look in your table to find the x-intercepts. So then the next thing would be your y-intercept. That would be where it crosses the y-axis. So if I look 1, 2, 3, 4, 5, it crosses at 5. And again, you could see that from your table right there. Okay, so the y-intercept is 5. So let's see, what else could we find? We could find the vertex, which is the turning point. So the vertex, the turning point of my parabola was right there. It's the one in the very middle where it turns. And so the coordinate of that one is at 3, negative 4. So you would write the vertex is at the coordinate 3, negative 4. And then they might ask you, is that a max or a min? And so you're going to ask yourself, does it have a top point to my graph or a bottom point? And so if you look, it has a bottom point to it. So that would be called a minimum to your graph, a minimum, okay? And then the last thing that they'll ask you key feature-wise would be the axis of symmetry. So the axis of symmetry, and you can shorten it. If you wanted to write like AOS for axis of symmetry, you can. Because I know some of you don't like to write more than you have to. But if you're writing the axis of symmetry, remember this is an equation, and it's the line that goes through the middle of it. So the line that would go through the middle of this would be about right there. And so you're looking for the equation of that line. So remember, it's a vertical line, and it hits the x-axis at just one spot. So it's going to be x equals, but then you have to tell where it crosses the x-axis. So you can look where it actually crosses, or remember, if you look at the x value of your vertex, which remember your vertex was 3, negative 4, it's going to be x equals that number because it's going to go through that vertex too. So either way you look at it, it would be x equals 3. That would be the equation of that line. You cannot just write a number for the axis of symmetry. Remember, it's a line, so you have to write the equation of it. Okay, so That's how to graph. That's how to tell the key features of a quadratic. If you had Desmos available to you, if you did not make a table and Desmos was available to you, remember you could type this in on Desmos and you could actually look at Desmos to get your graph. So like if you typed it on Desmos, notice all I did is I typed that equation in. It will graph it for you, and then to find your key features, you just tap like on the points. So that would be an x-intercept, that would be another x-intercept, that would be your vertex right there, that would be your y-intercept. So if you have Desmos available to you, that is an option. You can just type it in and then get it to tell you all your key features. But you still have to know what your x-intercepts are, what the vertex is, what the y-intercepts are, and all that. It just gives it to you rather than you having to make a table, okay? But remember, you won't always have Desmos available to you, so if they don't have it, you'll have to make a table just like I did and then find your key features. So.